Okay, we are now on the graphing chapter for little graphs. This is chapter 20 in the Heinemann book. And you have had graphing in the past. We did it last year. It was chapter 11. And in that graphing unit, we focused on linear equations and linear graphs. So this one's going to be adding to that. So you have the basic understanding of what to do to graph a line. So that was the y equals mx plus c. So in this unit, we will be looking at graphing non-linear lines. So, non-linear lines, it's kind of a ironic statement. Non-linear line is not a line, but non-linear equations. So if we look in the book, this is page 364, then you will recall for a line, for a linear graph, again, we have the generic equation y equals mx plus c. Just to refresh your memory on that, we have m is going to be the gradient, also called the slope. You can use those two interchangeably. To find the gradient or the slope, we did the difference in y over the difference in x. So that was y2 minus y1 over x2 minus x1. So you had to have two coordinates, and you would subtract the points from each other, and you would end up with the slope or the gradient. C gave you the y-intercept. So that is the point where the line actually crossed the y-axis. So where it crossed the y-axis, we actually had, if you look at a graph and think about it, this is the y-axis. Where it crosses the y-axis, x has to be 0. So that would mean the y-axis the y-intercept would look like this. Wherever x is 0, that's where it's crossing the y-axis. So 0, C. This x and y, that actually stood for the x and the y coordinates, and we could use those to substitute it in when we had coordinates to find the equation of a line. So this is just a review. This is what we've covered in chapter 11 in the last school year. So this hopefully will be something that you are familiar with and able to use. Something that you will notice about what makes a line is that the x here, whatever the coefficient, so we say coefficient's the number with x, in this case that's the slope, the coefficient of x, well, can't be 0, because if it was, we wouldn't have x. We wouldn't have an equation of a line. It would just be either a straight line, we would have y equals c. So the line y equals c, so if it was y equals 1, we would go to where y is 1, and the line would just be a horizontal line that way. Something else to notice about a linear equation is that x, the exponent of x, is 1. It's not written because we don't write anything to the 1 power. If we wrote 5 to the 1 power, it's just 5. So x to the 1 power is x, so we don't do that. It seems insignificant to do that, so we don't write it, just like you would write 1 times x. It's unnecessary. But that's what makes it a line. The exponent of x is 1. That's what's going to be different about some of these. Particularly, the quadratic functions is what we will begin looking at. For quadratic functions, so that's a linear, quadratic means, if you know from thinking back of the quadratic equation of when we would solve it, it means it has to have an x squared. That's what makes it a quadratic equation. You do not have to have c. It can be gone from the equation. If c is gone, so we could have the general form for this one, we would have y equals ax squared plus bx plus c. This is going to be a general form of the quadratic equation. So when we're looking at this, we know that a cannot be 0. If a was 0, then we wouldn't have a quadratic. We wouldn't have an x squared. It would just be a linear equation. However, we do not need bx, and we don't need c for it to be still a quadratic. What's significant is you just have to have this x squared. That's what makes it a quadratic equation. So, if you look on page 365, they'll give you some shapes of what it can look like. Essentially, if you have a quadratic equation, it's only going to look 2 different ways. It makes a shape called a parabola. if the parabola, if you have a quadratic equation where you have this coefficient of x squared, this a, if it's a positive number, it'll look like this. It'll look like a u. If this is a negative number, if the coefficient of x squared is negative, it'll look like this. The way I remember it is this to me looks like an n, kind of like an n negative, n negative. If you have a negative coefficient of x squared, it's going to look like this. If you look like this, it's like a happy face, smiley face. It's positive. So A is positive, smiley face. If it's negative, you can think of a frowny face or an N for negative. But these are the shapes that it will look like. So if you are asked to graph an equation and it does not look like one of these two shapes, you have somehow made a mistake someplace, so you can go back. So it's a good check to make sure that you've done it correctly. So in the example they're giving you, they're asking you to do just that, to plot, and we'll make some space here, to plot this equation on a graph. So they're giving you the equation y equals 2x squared minus 5x minus 3. And they give you the x values. They say between the x values of -2 and 4. That means when you go to make the graph, I actually did too many, you would only really have to go like this. You'd only have to go to -4 into 2. Generally speaking, I draw mine a little bit further out just to kind of get a picture of what it looks like, but you wouldn't have to go much beyond that at all. So the question is, how do we find the points to plot to do this? The way that we're going to do this is to make a table. That's the easiest, most straightforward way of writing this. So what we're going to do, they give you the x points. They say -2 to +4. So what I do is I make a table of that. So we have the x points. So along here we can put our x points. -2, -1, 0, 1, 2, 3, and 4. And then along this bottom side, I'm going to put each of these expressions by themselves. So that's 2x squared, that's going to be one of them. -5x. And -3. That one seems a little bit funny to put there, but that's going to give me y. So we can extend the table a little bit to get, that's going to give us the y point. So these are the x points along the top, and the bottom of this is going to give you the y points. So this is how we're going to do it. So already we know -3, this is the same because we haven't actually needed to do anything. So -2, I'm going to substitute, we have lots of practice from the functions unit in substituting, substitute this -2 in for x squared. So -2 times -2 is a +4, times 2 is 8. So I'm going to write an 8 down in that spot. Next we have -5 times -2. That's a +10. Okay, now we want to combine them. 8, these are both positive, so I'll treat them that way. 8 and 10 give me 18. 18 and -3 give me 15. That means one of the coordinates for this equation is -2, 15. So then we want to do the same thing with the rest of these. -1. -1 times -1 is a +1, times 2 is 2. -1 times -5 is 5, and then this is the same. So we have 2 and 5 is 7, 7 minus 3 is 4. Alright, 0. This one's a nice and easy one. 0 squared is 0, times 2 is 0. -5 times 0 is 0. So this is still going to give me just -3. 1 squared is 1, times 2 is 2. -5 times 1, -5, and then we have the -3. So we have 2 plus -5 is -3. -3 and -3 is -6. 2 squared is 4, times 2 is 8. You'll see something familiar happening here. 2 times -5 is -10. So here we go. So this one looks very similar except this negative sign. 8 and -10 is -2. -2 and -3 is -5. Then we have 3. 3 squared is 9, times 2 18. 3 times negative 5 is negative 15, and again my negative 3. 18 and negative 15 give me 3 minus 3 is 0. 4 squared is 16, times 2 is 32. 4 times negative 5 is negative 20, and then we have the negative 3. So we have 32 and negative 20 is 12. 12 minus 3 is 9. So we can make sure I didn't make any mistakes before we graph this. Alright, that's good. We didn't. So now we're going to plot the coordinates. Again, the coordinates that you have are going to be, these are your x points. They gave those to you. They told you what to plug in. You found the y points by plugging it in and then combining them. So if we look at this, we want to go to 15. So again, we begin with the x, go to 2, and then we go up to 15. If you notice, I labeled my axis with the numbers, but I didn't shove in every single number. I didn't do 1, 2, 3 all the way to 16. I counted by 2 so it wouldn't be so bunchy and so busy. So please do number it, but you don't have to do every single value. So there we go. 215 is this one. The next one is negative 1. I'm sorry, we went the wrong way. Negative 215 is on this side. Then we have negative 1. So we have left 1, 4. So that's going to be right on top of my 4 actually. 0, negative 3. That's going to be our intercept, or y-intercept. We can see here is when x is 0. Then we have 1, negative 6. 2, negative 5. 3, 0. And 4, 9. Now, this is the part where you have to actually go through and make as smooth of a curve as you can to connect the points. Do not use a ruler to connect these points. These are not lines from one to the next. If on the test you use a ruler to do this, you will not receive full credit. My suggestion to you when you do this is to do it all in one go. Don't do this like many lines. You can't have many lines connecting it. You can't do one of these things. It's got to be one straight thing. And to be honest, if you go too slowly, that is not going to be that helpful either. So if you go at a decent pace and try to, as best as you can, connect them. So you can see. Oop, I missed that one. Okay. So we did the best we could. Mine was a little off there. I'll kind of extend my... We have something like that. We want to do the best that we can. It's going to be especially significant when we get to later on in the chapter. You're going to have to find the slope at different points. So you want to do as best as you can. And probably I can do this part again. There we go. That looks much better. So don't be afraid to erase it and try again, but just don't have a million lines around it. You should have one smooth curve. So that's what that is going to look like. So again, please label it, and then on your graph, you should, in case you have two different equations, it would be helpful to actually label it on the graph itself also. So again, what we did was, we had the equation, they gave you the x values. They won't always give you the x values, but most of the time they will. If they don't give it to you, I would just basically use -2 to 2 or -2 to 4 or something like that. You want to get a mix of negatives and positives. So -2 to 4 they gave you. They said from the x values, -2 to 4. I put those on the top. I separated out the expressions within the equation, making sure I kept the sign. Keep the sign with it. This is a positive, assumed positive. And then we plugged in the values for each of them, again, being careful on this. Again, it's like a little parenthesis there, unwritten. Combine them, and that gave you the y value to go with the x value. And that gave us the coordinates. And you can see we had a +2. +2 means it's going to be a smiley face. And that's essentially, well, a crooked smiley face, but that's what we have. Also, you can see that my -3c gave us the y-intercept. So this is still the same c as the other equation. So this is still the y-intercept. So that will be a help to you as well when you're looking at it. If you made a mistake, then you will see. Because if this isn't the same value as that, again, it's the value that doesn't have an unknown with it, is c. then something happened in the drawing of this function. So this is a quadratic function that we're graphing. So it's going to look like a U, or it's going to look like an N. And that's the end of this lesson.